Okay, P11 static electricity. Draw the electric field lines around the charges below. So I've taught you, whoops, come on pen, pout and nin. So pout, positives, the lines go out, negatives, the lines go in. So I've got a positive there, I'm going to need pout, and it's just draw 4 equal lines around, mark, and then arrows out, mark. Describe how a cloth and a plastic rod can produce a negatively charged cloth. So it's important I explain why the cloth is negative when charging by friction. So I'm just going to do myself a sketch. So I've got my rod, I've got my cloth. At the start they'll have an equal number of positives, and negatives. Let's sketch that again. Positive, negative, positive, negative, negative, positive. So when I rub these together, we've got to remember that within solids we can only move the negatives, the little electrons, and the cloth has got to go negative, so the electrons have got to move that way. So those are going to move that way. There we go. So we're going to talk about where the electrons moving from, where are they moving to. So the two insulators will move electrons. That's a key word and is important. From the rod to the cloth gains a net negative charge. What will happen if two negatively charged objects are placed next to each other? So we know opposite charges attract, same charges repel. So these are the same charges, so they will repel each other because they have the same charge. And you can see I put the capitals and underline the keywords. The next one, a balloon is rubbed by a cloth and given a negative charge. Okay, so the balloon is negative. It will then attract to a wall. Explain why in terms of induction. So we said there's two main ways of creating charge. One by friction, rubbing two insulators, or the other one is by induction, where I use a known charge to induce a charge in a neutral object. So I've explained this in class before. A nice way of thinking about it is, here's my balloon that's negative. Here's my wall that's neutrally charged. There we go. Now when I bring this negative balloon close to the wall, it's going to push the electrons back in the wall. So I've got to say that. So the electrons get pushed back to the wall. Now the front surface, the front, will now have a net positive charge. And now we've got two opposite charges and they'll attract. And then over time, the electrons will leak back to the front and the balloon will fall down. So that's my diagram for it. Let's now check. So the negative balloon repels electrons from the front of the wall. The front of the wall now has a net positive charge and opposite charges will attract. So the negative balloon will attract to the positive front of the wall. And that's charging by induction. Next one, two opposite charges are brought close to each other. Draw the field lines that will be observed. So we know that they will attract. We know to use pout and nin. So now I can go line from there to there, line around the top, and they're going to go positive to negative because it's pout. And then I can then draw my other ones into the negative, out of the positive. There we go. And I wouldn't draw too many lines either. Keep it simple, and that way it's easiest to get the marks. The next one, a child gains a net negative charge when bouncing on a trampoline. They then touch the metal rail about the trampoline and gain a shock. Explain why in terms of electrostatic discharge. So we've got to talk about discharge. So if I go through, then I've got a child. They're all negative. Here's the metal hoop of the trampoline, and we can see it's connected to ground. So the ultimate part about this is this child now has an electric charge. So let's say that they're now 2 volts. Well, the important part is the trampoline is at 0 volts. So we now have a potential difference between the two. And then if that potential difference is greater than the resistance in the air gap, then electrons will flow across. So that's the important part. We've got a potential difference, and then if this potential difference of the child is greater than the resistance in that gap, electrons will flow through and through to the ground. I've tried to word that in a friendly way. So the child has a greater electric potential than the metal. I can just say that the child's at positive. The next one, the metal is grounded, that's at 0 volts. So there's a potential difference between the child and the metal, and this can push electrons across the gap, and then we'll get a spark, which will give them a shock. So that's it worded. You can see it's 2 marks, but I've put a lot of keywords in there. It's quite a difficult concept, and that's that all done.